Hey there, fellow philosopher. You ever find yourself really contemplating what's actually real, Like when we look at the world, are we seeing the basic building blocks of everything or just how those pieces fit together, the structures and relationships, I mean?
Oh, absolutely. That's a question that goes way deep, right to the heart of metaphysics and epistemology. And that's exactly the kind of problem, the whole intrinsic nature of things versus the patterns they make that structural realism tries to tackle. It's a pretty cool approach in philosophy of science these days.
And that's what we're diving into today, right? This deep dive is all about structural realism. And we're using, well, what a lot of people consider like the text on the subject, the Stanford Encyclopedia of Philosophy entry on structural realism. And let me tell you, it's dense.
It really is. It covers so much ground, all the different flavors of structural realism, how it links to metaphysics, logic, even philosophy of math, and of course, how it connects to what's actually going on in science.
Right. So we're going to try and break it down for you. As a philosopher, this stuff is important, but it's also super complicated. So we want to give you the core arguments, the main differences, and where the debates are, without drowning you in details.
Exactly. We want you to walk away with some real aha moments, something to think about.
Right. So where do we even start with something like this? Well, first, we got to get why structural realism even exists. Like, what problems was it trying to solve in the first place? Then we'll look at its two main branches, epistemic structural realism and onteific structural realism. We'll check out their main claims, what makes them strong, and where the problems are. And then, well, we'll see what all this means, in the bigger picture of philosophy.
Sounds good to me. Let's set the scene first, though. For ages, philosophy of science was basically a battle between scientific realists and anti-realists. Scientific realists, well, they think our best scientific theories are basically true, right? Like they describe the world pretty accurately, even the stuff we can't observe directly, like all those tiny particles and whatnot. And their main argument is this no miracles argument.
Yeah, it's kind of common sense, isn't it? Science is so successful at explaining things and predicting stuff. It'd be a huge coincidence if our theories weren't at least kind of right about what reality is like.
Exactly, but the anti-realists had some good points too. One was the underdetermination argument, which says you can have tons of totally different theories that all explain the same observations. But the one that really pushed things towards structural realism was this idea of radical theory change. Like, science changes a lot, right?
Oh, yeah, the pessimistic meta-induction.
Yeah.
It basically says, hey, look, lots of theories we thought were great turned out to be wrong. Think of like phlogiston in chemistry or the ether, that stuff they thought light traveled through. If those turned out to be wrong, how do we know our current theories aren't going the same way?
Right. It created this kind of deadlock. Either you believe in descriptions of things that might be totally wrong later, or you just say, well, science can't tell us anything for sure about the real world. So in 1989, John Worrell came along and said, hey, maybe there's middle ground. Maybe we can get the best of both worlds. And that's where structural realism comes in.
So how did he try to fix this whole mess?
Well, he looked at some big changes in scientific theories, like the shift from Fresnel's theory of light with the ether and all that to Maxwell's theory of electromagnetism.
Huh.
And he saw that, yeah, the basic things they were talking about were totally different, like a physical substance for light versus electromagnetic fields. But there was something that stayed the same. And it wasn't just the predictions they made.
This is where things get interesting, right?
Exactly. What stayed the same was the math. The equations, the relationships they described, that stuff survived even though the picture of what was actually going on changed completely. So his first version of structural realism was all about knowledge, what we can know. He said, maybe we should focus on the math, the structure of our theories, instead of worrying about what those unobservable things actually are.
So we can be realists about the structure, the way things are organized, but we don't have to say what those things actually are made of.
Right.
That's the heart of epistemic structural realism. And by focusing on structure, it kind of gets around the pessimistic meta-induction thing, because we're not saying those specific descriptions of particles or whatever are true. But it also explains why science is so successful, especially at making new predictions, because it says those relationships, that structure, is reflecting something real about the world. It's like, imagine a gear, right? We might not know what tiny particles make up the gear, but the way they're arranged, how they fit together, that's what makes it work. And that's what we can use to predict how it'll work in the future.
That's a great analogy. And, historically speaking, these ideas weren't totally new. If you look back, philosophers of science in the late 1800s and early 1900s, people like Poincaré and Duhem, they were already playing around with similar ideas, especially with physics becoming more and more mathematical. Poincaré, he was really into Kant, and he thought structure was key to how we understand things. And Duhem, he thought the relationships and scientific laws were real, even if he wasn't sure about the actual stuff they described. So Worrell was kind of building on those earlier ideas, giving them a more modern spin.
Okay, so we've got the motivation, why structural realism even came about. Now let's dive into the two main types: epistemic structural realism, or ESR, and onychic structural realism, OSR. Let's start with ESR. What's the deal with that?
All right, so ESR, it's basically saying that science can only tell us about the structure of the world, not about the actual nature of the stuff that makes it up. It's saying there's a limit to what we can know scientifically. We can figure out the how, the patterns and connections, but not the what, the fundamental essence of things.
So we know there are things with certain properties and they interact in certain ways, but we can't know what those things really are deep down.
Yeah, that's a common way to put it. But even within ESR, there's disagreement about exactly where that knowledge limit is. Some folks, they take a really strict view. They're inspired by later Russell and Carnap, and they say science can only show us the logical skeleton of the world, like the relationships between relationships. Others, they're a little more lax. They say we can know about the relationships themselves, just not the individual things or any properties they have that aren't defined by those relationships. So there's a whole spectrum of views within ESR.
The entry talks about an upward path and a downward path to ESR. What's that about?
Ah, right. So Seelos, he described these paths. The upward path is like, you start with empiricism, the idea that all knowledge comes from our senses. And from there, you try to show that the only things we can really figure out about the unobservable world are its structural features, because that's what we see reflected in our observations, indirectly. Russell's epistemology is a good example here. He thought we only have direct access to our sense data, and the relationships between them mirror the structure of the things causing them. The downward path is kind of the opposite. You start by believing in scientific realism, the standard version, and then you weaken it bit by bit. You say, okay, we should only believe in the structural parts of our theories, not the specific descriptions of unobservable things, like Worrell suggested. But both of these paths, even though they end up at ESR, they have their own problems, philosophically speaking.
It sounds like the main idea in ESR is that what we can know is limited by how we observe and theorize things, and that's all about relationships. Now, the entry also talks about some Kantian stuff in ESR, especially with Poincaré. What's that connection about?
Well, Poincaré, he was big into Kant, like I said. He thought the unobservable things in scientific theories were kind of like Kant's noumena, the things in themselves, the stuff we can't directly experience, so we can't directly know. But, he said, we can still learn about them indirectly, specifically about the structural relationships they have. He saw science as figuring out more and more about those structures, even if our ideas about the actual things themselves changed over time. And Zahar, he has this explicitly Kantian version of ESR. He says science can only ever show us the structure of this noumenal world. The actual nature of the stuff in it is always going to be a mystery to us.
So it's like our theories give us a map of the relationships in reality, but we never actually see what's at those points on the map. The actual things themselves are like hidden. Very Kantian.
Yeah, exactly. And this focus on relationships instead of intrinsic properties, it also connects to Ramsey's sentences in ESR. Are you familiar with those?
Refresh my memory. How does that approach help us understand structural knowledge?
Okay, so the Ramsey sentence thing, guys like Grover Maxwell were big on it. It was a way to make scientific realism and empiricism play nice, and to explain how we can know about unobservable things even though we can't directly see them. So you take a scientific theory, all formal and stuff, and you replace all the terms that refer to unobservables with these variables, like in math. So instead of saying electrons have negative charge, you say there exist some things that have this and that relationship with other things, and those relationships cause what we observe.
So you're basically saying there's something that fits that role in the theory, but you're not saying what it actually is.
Right.
Like just that it has those relationships.
Yeah, exactly. And Maxwell and Russell, they argued that this structural knowledge, that's all we can really know about the unobservable world. We know something's there, and it has those relationships, but we don't know what it is intrinsically.
But then there's this whole Newman's problem thing. That sounds like a pretty big wrench in the works for ESR. What's the problem there?
Yeah, Newman's problem, it's a tough one. It basically says, hold on, just knowing the structure isn't enough to tell you anything specific about the world. It was first brought up in 1928, And it challenges this whole idea that structural knowledge, like what you get from a Ramsey sentence, gives you real information about the unobservable stuff. The problem is, just knowing the structure of a bunch of things doesn't tell you what those things are. Any group of things that's big enough can be arranged to have the same structure.
Let me see if I get this. If your theory just says there are like three things, and they're related in a certain way, say A causes B, and B causes C, that could be true for a bunch of different things, right? It doesn't tell you what A, B, and C actually are.
Oh, exactly. Demopoulos and Friedman, they really went to town on this objection. They said, look, if all we know is the truth of the Ramsey sentence, then it's basically just saying the theory is consistent, its observations are true, and we know how many unobservable things there are. That's not much. They said it makes ESR basically collapse into a fancy kind of empiricism where any theory that makes the same predictions is equally good, and we're not actually learning anything about the unobservable world except its basic structure.
Ouch, that's gotta hurt. But the entry mentions some ways to get around Newman's problem, right? Something about mixed predicates and intentional notions.
Yeah, some folks try to defend Ramsey sentences by saying, hey, we can keep some terms that apply to both observable and unobservable stuff, like spatial or temporal properties. They say that by keeping some direct links between what we can observe and what we can't, the structural description becomes more specific, and you avoid that whole permutation argument that Newman uses. Others say, let's add in some intentional stuff, like how natural a structure is or how important it is causally. They think that helps us pick out the right structure, even if there are other structures that look the same mathematically. But, those responses have their own problems, too. Some argue they don't really solve the core issue. Lady Harcum, for example, he says even with those tweaks, epistemic structural realism can't deal with the fact that what we think exists changes radically when scientific theories change.
So ESR is interesting, but maybe not a perfect solution. That brings us to onoctic structural realism, OSR. How is that different from ESR?
Okay, so OSR, this is where things get really wild. ESR is all about what we can know, but OSR is about what's actually real. It says structure and relationships, those aren't just what we can know, they're the most fundamental things in reality. It puts structure ahead of individual objects and their properties.
Whoa, so it's not just that we can only see the structure, it's that reality-ias structure deep down.
Yeah.
That's a pretty big shift.
It is, and a lot of the motivation for OSR comes from modern physics, especially quantum mechanics and space-time stuff. Like, think about quantum statistics. They mess with the whole idea of individual particles, right? Or quantum entanglement, how things are connected even when they're far apart. And math is so important in our best physics theories, expressing all these symmetries and relationships, that it makes some philosophers think maybe structure is more basic than the things that have it.
It's like flipping our usual way of thinking. We usually think of things as existing first and then having relationships, but OSR puts relationships first.
Totally. The Stanford entry talks about a bunch of different versions of OSR, some crazier than others. The most extreme one is eliminativism. It says there are no individual things at all, just structure.
No things, just relationships, but nothing for them to relate. That's hard to wrap my head around.
Yeah, it is, and it has problems, of course. Like, how can you have relationships without things to be related? Sillos and Van Frassen, they argue that eliminative OSR mixes up abstract mathematical structures with actual physical reality. But guys like French, they defend it. They say what we see as individual things might actually be emergent. They come from the underlying structure somehow.
Okay, that's getting pretty deep. What are some of the other, maybe less intense versions of OSR?
Well, another big idea is that some basic relationships don't depend on the things that are related, like quantum entanglement. That's the classic example. Those correlations between entangled particles, they seem to be fundamental. They're not just because the particles themselves have certain properties. This challenges those traditional ideas like Humean supervenience, which says everything in the world is just a bunch of local facts and everything else depends on those facts. Maudlin, he says, entanglement shows the world isn't just a bunch of separate independent things with their own properties.
So quantum mechanics is saying things are connected in a way that can't be explained by just looking at the things themselves. The connection itself is important.
Exactly. Then there's this idea that maybe things don't have intrinsic natures at all. Like, all objects of the same type are exactly the same, and the only thing that makes them different is how they're related to other things. This connects to the principle of identity of indiscernibles, that two things can't be different if they have all the same properties. Identical particles in quantum mechanics, they kind of mess with that principle if we say they're individuals with their own properties.
Right.
So some OSR folks say, well, maybe they're not individuals in the usual sense, or maybe their individuality comes only from their role in a system, how they're related to other things.
So their identity is about where they are and how they interact, not about some internal essence that makes them unique. Yeah.
Right. There are other versions too, like the idea that things don't have any intrinsic properties that can't be reduced to relationships, or that the identity of a thing depends completely on the relationships it's part of. Saunders, he has this idea of weak discernibility in quantum mechanics, where particles are distinguished by relations that aren't reflexive, they don't apply to the thing itself. And then there's the view that there are no independent objects at all, only structure exists, which is kind of like quantum holism. And finally, there's the idea that objects are just concepts we use. They're not really fundamental to reality.
Wow, that's a whole different way of looking at things. And it sounds like OSR is really tied up with how we interpret modern physics.
Mhm.
The entry talks about its connections to group theory, quantum field theory, and space-time physics. Could you break those down a bit?
Sure. Group theory is all about symmetries, and it's really important for OSR. Guys like Poincaré, Cassirer, Born, Weil, Eddington, they were all into this. The basic idea is that you can describe an object by how it behaves under certain transformations, changes. Weil said that being invariant under those transformations, that's what makes something objective. So in OSR, they think of particles as basically being those invariant things under the symmetry groups in particle physics. The group structure itself becomes the fundamental thing, and particles are just like specific ways that structure shows itself.
So instead of the particle being the basic thing, it's the symmetries that are basic, and the particle is just one way those symmetries can manifest.
Yeah, that's the idea. Then you have quantum field theory, QFT. The whole concept of a field, it challenges the idea of particles as individual things. In QFT, particles are like excitations of the field, and the field itself can't always be broken down into a specific number of particles with their own identities. That fits nicely with OSR, which focuses on fields and their structure. And then there's gauge symmetries in QFT. They cause a lot of trouble for the idea that fundamental objects are located in space and time and have their own properties. Philosophers like Lyell, they say focusing on the structure of those gauge symmetry groups is a better way to understand what really exists.
What about space-time physics, especially general relativity? What does that have to do with OSR?
Well, there's this thing called the whole argument in general relativity. It shows that you can't tell space-time points apart just by their mathematical properties because you can transform them without changing anything physically. This has led some people to say that what's really real is the structure of space-time, the metric field that describes gravity, not the individual points themselves. Some philosophers like de Salle and Pooley, they've come up with versions of substantivalism where space-time exists, but the identity of points depends on their relationships. That fits with the whole OSR idea that relationships are fundamental.
So OSR gets a lot of support from some of the weirdest and coolest parts of modern physics, and it offers a really different way to think about what's real. But like ESR, it has its problems too, right? Besides Newman's problem, I mean.
Oh, definitely. One big objection is that not all structure survives when scientific theories change. Like, sometimes even the math changes completely. If structural realism wants to be about what's likely to be true in the future, that's a problem. But structural realists usually say, hey, the empirical content, the relationships between observable things, that's what stays the same, at least in the most basic sense.
But even if some math stays the same, the meaning of it can change a lot, right? Like maybe it's not the same structure anymore, just the same equations.
Right, that's a valid point. Another big criticism, especially for OSR, is that it's not really a fully developed metaphysics. People like Silos, early on, they said OSR just says structure is important, but it doesn't really say what structure IS or how it connects to our everyday experience. There's been more work on OSR since then, but it still needs more fleshing out. And some people say structural realism can't explain causation. Usually we think of causation as things interacting and changing each other, and it's not clear how that works if structure is the most fundamental thing. But OSR people have some responses to this. They talk about modal structure, like how theories describe what's possible and necessary, and they say that can explain causation. Or they say causation is just our way of talking about what's really happening at the structural level.
And then there's that coincidence or object question.
Hmm.
It seems like when properties always go together, like mass and charge and an electron, it makes sense to think there's an object that has those properties, not just a bunch of coincidental relationships.
That's a good point, and it's a tough one for OSR. French, he says, well, in OSR, objects are those stable patterns of relationships. You don't need another thing that has them. But critics say OSR needs to do more to explain why those patterns are so stable, why those properties always go together, without resorting to the idea of an individual object. Maybe this idea of real patterns could help. It's from Dennett, and people like Ladyman and Ross are using it in structural realism. They say that when patterns are stable and we can use them to make predictions, maybe we should say they really exist in some way.
And then there's Van Frassen's big objection, right? If reality is just structure, and our best theories use math to describe it, how do we know the difference between a physical structure and just some abstract mathematical structure?
Yeah, that's a big one for OSR. Van Frassen says that just talking about structure isn't enough to tell if it's in the world or just in our heads. Some radical OSR people, like Tegmark, they just say, hey, reality is mathematical structure. But most OSR folks want to keep those separate. They say the math in our theories represents the modal structure of the world, like the possibilities and necessities that govern things. But it's not the same thing as the structure itself. But how that representation works, how it makes the structure physical, that's still being debated. It's connected to some old problems in philosophy of math, like Benacerraf's problem about what mathematical terms actually mean. And some people criticize structural realism in general. They say the whole idea of structure is just too vague.
So structural realism is a super interesting way to think about reality and scientific knowledge, but there's still a lot to figure out.
Yeah, it's a really active area of research.
So to wrap things up, for all you philosophers out there, what are the main takeaways from all this structural realism stuff?
Well, structural realism makes us rethink some of our most basic assumptions about what exists and what we can know. It challenges the idea that individual objects are the most important thing and suggests that maybe relationships and structure are more fundamental. This changes how we understand science, what our theories tell us about the world, and what their limits are. It brings up all these old philosophical questions about realism, empiricism, what exists, and even what it means to exist. Whether you agree with structural realism or not, thinking about it helps you examine your own ideas about reality and how we can know it.
So here's something to think about. If reality really is fundamentally structural, what does that mean for philosophy itself? Does it mean we should focus on figuring out the basic relationships and patterns instead of looking for the basic building blocks of everything? Maybe philosophy is about mapping out the structure of thought and reality instead of trying to find some ultimate fundamental thing.
That's a great question. It makes you think about what philosophy is really trying to do. And hopefully, this deep dive has given you some tools to explore those questions further. If you want to learn more, check out the stuff we mentioned and read more about structural realism. It's a really fascinating area of philosophy.